Hello guys, welcome back to the channel. In today's video, we introduce and familiarize ourselves with the concept of buffers and streams as they are applied in Node.js. Streams and buffers are not unique to Node.js. They are fundamental computer science concepts used across many programming languages and systems. And in today's video, you understand how they are implemented in Node.js and how to use them when building everyday applications. Okay, if that makes sense to you, then absolutely smash that like button. Ensure you subscribe to the channel so that you can get access to all of our videos in the future as they drop. So let's jump into what we have for today, starting with buffers. What are buffers? In simple terms, a buffer is just a temporary storage location for binary data. This is related to when we are moving data between processes, okay, or when we are trying to do large-scale input or output operations. Buffers are Node.js solutions for handling raw binary data, okay? They act as phase size allocations of unmanaged memory outside of the V8 heap. They are essential for working with streams in Node.js. Buffers are a reliable way for us to handle that type of data because at the end of the day, JavaScript from the core was not built to deal with this kind of data, and they are provided to us by the runtime Node.js. So let's move on from that and let's see how we can create a buffer in Node.js. There are different ways to create buffers in Node.js, but the first method we are going to look at is the buffer.alloc method. So let me go ahead and create a buffer with that. I'm going to say first safe buffer is equals to buffer.alloc. I'm going to give this 5 bytes. Then I'm going to print it out to the console. Okay, console.log safe buffer. I'm going to save this and I'm going to come into the terminal. I'm going to say node index.js. To run this, I can see that we get a 0 field buffer. There's another method for creating the buffer other than the buffer.alloc method. Okay, we have the unsafe allocation, which is buffer.alloc unsafe. We're going to look at the distinction between these two different methods of creating the buffer shortly, but first of all, let us see how the buffer.alloc unsafe method works. Okay, so I'm going to go ahead and say const unsafe buffer is equal to buffer.alloc unsafe. Let's make this 10. Okay, and I'm going to go ahead and console log unsafe buffer, and I'm going to attach this to the unsafe buffer just created. To go ahead and come into the terminal and run node index.js on the terminal, I can see that we get these two different array buffers. What's the distinction between this buffer.alloc and buffer.alloc unsafe method? Okay, you should know that these two are the most basic way to initialize a buffer. However, that they are not the only way, as there are other ways to create buffers in Node.js. We can also create a buffer from an existing data source. See, the difference is that it is generally more considered safe to use buffer.alloc because it creates a 0 field buffer, which is essentially an empty buffer. Using buffer.alloc unsafe is considered to be unsafe because the buffer created might contain some data which has been stored in memory from previous operations. Okay, so now we have moved on from that and we have seen two different ways you can initialize an empty buffer. Okay, let's see how we can create a buffer from an existing data source. I'm going to go ahead and wipe this all out, and I'm going to show you how we can create a buffer from a string. First, I'm going to say const str buffer is equals to buffer dot from. I'm going to just call this new underscore buffer. Okay, then I'm going to go ahead console.log this at string buffer. I'm going to console log the str buffer we just created. I'm going to run this file from the terminal. I can see that we get this string buffer. You can see this new string buffer we just created in our console. Okay, we can also create a buffer from a base 64 string. Okay, we can also create a buffer from an existing array or an existing array buffer. But first of all, let me show you how to create a buffer from a base 64 string. So I'm going to go ahead and say const base buffer is equal to buffer dot from tm9kzs5qcw equal to, and this is going to be what? This is going to be in base 64. Okay, we're going to go ahead and console log this base buffer we just created. I'm going to come into the terminal and run this file from the terminal again. I can see this base buffer that we just created. Remember, I told you that we can create a buffer from what? An existing array buffer. So let's look at that method next. I'm going to go ahead, come under here, and create a new variable named array buffer buffer is equal to buffer dot from, and this is going to be, let me just copy this value here and I'm going to paste it inside of this array, add a comma to each one of them. I'll get rid of the alphabets. I'm going to go ahead and console.log this array buffer into the array buffer variable, and I'm going to run this file from the terminal. I can see that we get that array buffer. Okay, so these are the three different methods of creating a buffer from an existing data source. Okay, so now we have seen what buffers are. We have also seen how we can create a buffer from an existing data source. The next thing we are going to look at is some important properties of buffers. So I'm going to get rid of all of this except the string buffer, and we are going to first of all look at the length property of a buffer. Okay, so I'm going to go ahead and console log the length, and this is usually stored in the str buffer dot length. I'm going to save this and I'm going to run it from the terminal. I can see that we get 10, and this should be equal to 10. Exactly is equal to 10. Next party of buffers we are going to look at is the underlying array buffer, and that is stored in the variable named buffer. So I'm going to console.log this, and this is going to be underlying buffer, and it is usually stored in str buffer.buffer. Okay, and I'm going to save this and I'm going to run this on the terminal. I can see the underlying array buffer. Okay, the next property we are going to look at is the byte offset property, and I'm going to just output this out in between the length of the buffer and the underlying array buffer, and this is going to be byte offset. Save this, go to the terminal, run it. I can see that the byte offset is what, 8. Okay, so now we have seen some important properties of buffers. Let's look at how we can manipulate buffers. Okay, and by manipulating buffers, you're going to see how we can fill up a buffer, write into a buffer, copy a buffer, and copy buffers from one memory address to another. Okay, so let's see how we can fill a buffer. I'm going to initialize a zero field buffer by creating a variable buff, which is equals to buffer.alloc. Okay, and this is going to give us 10 first. Then we are going to fill this buffer with some values. Okay, this fill method fills a buffer with some value. Okay, and it changes all the array elements from start to end. You can see that it accepts a value, which is the value we want to fill this array with, a start index and end index. Okay, the start index is where we want to start to fill the array buffer from, and the end index is where we want to stop. Okay, so this value is going to be value. Okay, so now we have done that, I'm going to go ahead and print out this buffer to the terminal. I'm going to say console.log buffer, and this is going to be buff. Save this, go to the terminal. I think we need a new terminal because this one is messed up. I'm going to run node index.js. I can see that we get a buffer. Okay, so the fill method is used to fill a buffer object with a specified value. It modifies the existing buffer, replacing its contents with the given value. The fill method returns a reference to the original buffer which has been modified. Okay, and we have talked about the arguments that this method accepts earlier. So the next method we are going to look at is the write method. So I'm going to go ahead and replace this fill here. All right, so what's the difference between this write and the fill method? First of all, let's look at the write method. The write method is used to write a string into a buffer at a specified position. It allows for precise control over how data is written within the buffer. This returns the number of bytes written into the buffer. Okay, this is going to be bytes, and we are going to console log out these bytes, so we'll see how many bytes that was written. I'm going to save this and I'm going to go ahead and run this from the terminal. I can see that we have 5 bytes written and we have the underlying array buffer. Okay, so let's hover on this write method to see any extra descriptions on it. Okay, so this write method accepts a string, and offset, which is where we want to start the writing into the buffer from, the length, a length property, which is the length of the string we want to be written from that string into the buffer, and we have a source start, which is where we want to start to write that string from, and a source end. So the next method we are going to look at is the copy method. The copy method allows us to read a sequence of bytes from a source data starting at the source start, ending before the source end, and write them into a target buffer starting at the target start. So let's look at this copy method shortly. Okay, I have this buff variable I have created here. I'm not going to mess with it. I'm just going to leave it the way it is, and what I'm going to do is to now copy this into a new buffer. So I'm going to create a new buffer named target, which is equals to buffer dot alloc. I'm going to give this, let's say 20. I'm going to buff dot copy. I'm going to copy it into here, the target first of all, right? This is going to be 0, this is going to be 1, and this is going to be 10. Let's write some buffer into this by calling buff dot write value. So I'm going to now go ahead and console dot log the targets. Okay, so I want to output the targets right before we run the operation the first time. That's before we call the copy command. So let's see what the target buffer looks like before and after the copy function is fired. You can see that initially when the target buffer was created, it was 0 filled, but right after we copied from buff into target, you can see that some values are written into the buffer. So this is how the copy method works. Okay, there is one more method that allows us to manipulate buffers, which is the slice. Okay, this buffer dot slice basically creates a shallow copy of one buffer. So I'm going to go ahead and replace this copy with a slice. Okay, at the end of the day, there isn't much difference between the slice and the copy method. Okay, the only difference is whereby the copy method is going to create a new array buffer from scratch. The slice method is just going to create a reference to an existing buffer. Okay, so let me just show you how the slice method works, and you can see that nothing happens to target. So let's try to slice the buffer. I'm going to delete all of that. We have this buff variable we've created and we are written into it. And I'm now going to say this equals to buff dot slice. Okay, this is going to be 0 and this is going to be 5. Okay, then I'm going to go ahead and console.log target, and let's see what target now looks like. And what will happen if we console.log buff? Let's console.log buff and see. You can see that they are the same, although buff is longer than target. Now what will happen if we change buff after we manipulate target? I'm going to still write some more values. So I'm going to say buff dot write. This is going to be a space and this is going to be hello. And now let's still console log the both of them under and see what happens. Any change we are making to buff is affecting target, although you can see that target seems to have run out of space. So let's increase this to 10 and let's see what happens to target this time. I can see that anything that happens to buff is exactly what is happening to target, matching what I told you that a shallow copy is being made. So now that we have seen how to initialize an empty buffer, create a buffer from data source, and manipulate buffers, the next thing we are going to look at is how to convert buffers into strings and JSON. Okay, buffers have this toString method, and I'm just going to call that on this target here by calling it toString, and this is going to be a UTF-8 string, and I'm going to console log this out. You can see that we get hello. Amazing, isn't it? Now we can also convert the buffer to JSON by calling buff dot so JSON. Okay, and I'm going to run this on the terminal. I can see that we get an amazing JSON object for this buffer. Isn't that wonderful? The next thing we are going to look at now is streams. Okay, so if we say that buffers are a way to initialize unstructured data or a way to handle data sources in Node.js, we can say streams are designed to process buffers. Okay, and the name streams is quite self-explanatory in its own, because at the end of the day, that is how buffers are processed in Node.js. Okay, so you can think of the buffer as the water source, where if we want to collect bits by bits, it has to flow downstream. Okay, so while it's going downstream, we can now do something to the water. Okay, we can fetch it, we can wash, we can cook in it, and all those processes is what we can broadly classify as what transforming the data. So that is what streams are. Streams are a way to handle data sequentially, especially useful for large amounts of data. So instead of loading the entire data set into memory, streams process data in chunks using what buffers. Okay, this approach improves memory usage and performance. When a stream is being read from, Node.js reads a chunk of the data into a buffer and then emits a data event, which allows the consuming code to process the data. When a stream reads a data, it stores each chunk of data in a buffer. Again, this allows data to be processed and manipulated before being passed along. So you can see that buffers are inherent to streams, and in order for streams to work efficiently, they have to use buffers. That is why I told you that if our buffers are a data source, streams are a way for us to process that data sequentially, bit by bit. So there are 4 main types of streams in Node.js. Okay, writable streams, You have readable streams, duplex, and finally transform streams. Okay, now let's start with writable streams. Writable streams are streams that allows us to write data into a buffer. Okay, so an example of a writable stream might be the fs.create stream, which is used to create a file. Let me show you how that works. I'm going to go ahead const to import fs by saying this is equals to require fs, and I'm going to say const 5 is equals to fs dot create write stream, and this is the path. I'm going to say this is going to be file.txt. Now this is a write stream, and how do we know this is write stream? Because every write stream must have a write method that allows us to write a data into the stream. Okay, and I'm going to demonstrate this by writing some text into this file by saying file.write. I'm going to write hello world, and this allows us to process errors. So if there are any errors arising from this app, I'm just going to console.error that error. I'm going to save this. I'll be to run this from the terminal. Now we have rolled this file from the terminal. You can see that we have a new file created here, and if I go to this file, you can see that we have hello world inside of it. Okay, and we get null back because why? We didn't get any error here. So that is what writable streams are. So if writable streams are streams that we can write to, what about readable streams? Readable streams are streams that we can read to. So I'm going to comment these ads. I'm going to also comment these ads. I'm going to delete this because we don't need it anymore, and I'm going to show you how readable streams work. Okay, since we wrote into the file.txt file, the next thing we are going to do is to try to read from it. So I'm going to const stream is equals to what? fs.create read stream, and this is going to create this thing into a file.txt. Then I'm going to say stream.on data. What do we do with the data? I'm going to create a new variable str, which is equals to an empty string. This is going to be let, so we can change it later. And we are now going to come back into this event, and we are going to say str is plus equals to data. Okay, right? Then I'm going to console.log data. When we are done, let's see for the end event on the stream, and that is end event. We are going to what? Console.log the strop. Then I'm going to run this file from the terminal. I can see that we get what? Hello world. Exactly what we wrote into that file. Now, isn't that wonderful and amazing? Indeed, it is. Okay, so this is what readable streams is about. We will have taken our time to look at what duplex transform streams are, but those will require some complex code. Okay, although there are also built-in interfaces or built-in classes that can be classified as duplex streams. Okay, that is the implement, the read, and the write method. Things like a TCP socket implements a duplex thing. Okay, and when you're working with a cryptography module in Node.js, you're going to work with a lot of transform streams. Okay, and transform streams basically take any data source and then you transform it to produce another output. I'm going to be looking at this cryptography module shortly and how we can secure our applications in Node.js. Okay, inside of this video, I'm going to show you how you can bypass using some unnecessary libraries which bloat your application and see how you can secure your users using your own code. Okay, make sure you subscribe to the channel so you can get access to that video when it drops, and I'll see you in the next one.